So first, I'm going to, of course, before I share the use cases and what Hadoop can do for you, a little background is good. So I'm going to talk about why Hadoop is important and what problems in the industry has led to this technology being so hot. I'm also going to talk about a high level, the Hadoop ecosystem, all the components, but trying to explain them in pure English. And then I'm going to talk about the actual use cases, the most typical ones that our customers deploy in production today. And also, my favorite part of this talk, I hope we get to it, is to talk about my top 5 favorite use cases that are a little bit more advanced than the common one. So our industry is data challenged. What do I mean by that? Well, first of all, the volume of data is growing exponentially, pushing our traditional storage and processing systems to the max. Many organizations can't really cost efficiently scale with the traditional storage systems. It will break their IT budgets if they have to invest in as much data storage and processing systems that should actually host all the data they need to save and store and process. This means that many organizations are forced to prematurely archive data, which then limits the timely access to such data. It also forces organizations to choose what data to save in the first place, keeping only the necessary, which then limits the chances of getting back and getting bigger insights across that data at a later point in time if your business needs happen to change. This volume also puts pressure on coming up with more efficient ways to process the data. You still might have the same SLAs and same fixed time window. And imagine then pushing more data through that time window. You need a system that can scale out the actual processing phase. How do you do that? And also, in today's society, we generate more data in a faster pace than we've ever done before. So there's this rapid pace of data coming in just systems need to scale out as well. The third challenge in today's industry is around the new types of data. This might be the most hot topic and most talked about, what value can we actually extract from Twitter data or geographical location from your cell phones, text messages, or all these new forms of data that we generate in faster pace, like images and videos and even voice recordings. What can we extract from all this information to better get to know our customers, our patients, our clients, or our society and environment in general? Traditional systems here, again, suffer from the pain of being a little bit inflexible. Traditional systems require you to define what structure this data should be stored with up front. So in a database, you need to decide the table and the columns and the different fields and data types you're going to save there. And that basically means it arrogantly assumes that you know all the questions you're going to ask on that data up front. It makes you ignore the business might change down the road and need to aggregate Twitter data with traditional customer records or something else. So how do you efficiently and cost, within cost reasonably sized budgets, handle this new type of data? Remodeling is not easy, and it's impacting your data center and operations costs. So those are the challenges in today's industry around data, and what has that led to? Well, organizations are striving to rethink data. What if we don't have to fit into traditional systems? Are there other alternatives that are more cost efficient? What if we can find other technologies that doesn't force this structure up front? And there are many different ideas and innovation over the last years out there in this area of problem, right? The two drivers that has emerged, at least from my perspective, in my experience, are we want to do the same thing we usually do in our traditional environment within the same fixed time window, but over larger sets of data. Or we want to do more complex queries because we have more complex business needs, but those queries take too long to even respond, or the data is located in archived systems, so we have to pull it back, and that takes 4 weeks in our organization, so I can't really wait for that anymore. So this access, immediate access to data, and also cost-efficient system to enable that is one core driver in organizations that I see that are, wait for it, looking at Hadoop. But I'm going to get into Hadoop very, very soon. Another big driver is more on the visionary side. What's next? What new competitive solutions or offerings or business ideas can we provide to win in a more and more competitive market where services start to be more important than sometimes the actual product? You know, how can we optimize our processes in our organizations? How can we provide customer support? How can we meet the customer where they are when they need us to meet us there? Is there anything hidden in all this new data that we can extract to help us get there faster? And this part is actually where I burn the most for this technology, because this is where new innovation can truly happen. I've seen some fantastic use cases, and I'm going to talk about them at the end. But basically, the concept of this new data, what can we aggregate old data with new data, what insights can we get from it, is hidden in the sentence of there's no longer a box. There is no box. We can think about questions across all our data. We don't have to limit ourselves to think in that predetermined table of databases and data warehouses that we've been forced to limit ourselves to. So Hadoop comes around 5 or so years ago and saves the day. Well, smiling. I mean, no solution is perfect, right? There is no silver bullet, but it's a promising technology, and it's already been adopted worldwide in big companies. Fortune 500 companies are running this in production today, and they have shown real value, and it's here to stay. So yeah, it comes to save the day. Why? Well, on a very, very high level, these are the key promising features of Hadoop and its ecosystem. Scalable storage and processing weaved together through the simple architecture of taking the data, split it up into equally sized chunks, laid out beautifully across commodity hardware, no special sauce. Then put a framework on top of it. Let that framework contain the logic and also the capability of extracting that information you want to do something with. All done in parallel on these equally sized chunks allows this technology to scale linearly. If you have equally sized chunks that all are executed logic upon in parallel, there's no stopping adding more nodes to it and expanding the processing capacity in a linear way. The other beauty of Hadoop is the structure at query time. You don't have to decide up front what structure you're going to apply, what questions you're going to answer with that form of data. And you can easily change your mind down the road and apply structure whenever you want to find out something new. You design a new structure and apply it onto the data at query time. So structure is separately stored and hosted from the data. In traditional systems, it's weaved together. So this brings a lot of flexibility to ask any questions when your business needs change. A common deployment model, moving into a little bit closer to reality now, is to deploy and use Hadoop as an enterprise data hub. This is a new architectural concept that came around last year. So it's very fresh to put a name to this concept. It's a landing zone for all your data where you can store it forever, cost efficiently. And then as new use cases comes up, new needs for scale, you can either bring those workloads into work natively on where data is stored inside this enterprise data hub, or you can pre-process it there and then serve it through specialized systems elsewhere in your data park. So the enterprise data hub is the landing zone for data. It allows scalable and cost-efficient processing. Some workloads operate natively. For other use cases, you serve it through expert systems. So the ecosystem, I talked about Hadoop. What is it? Well, it's a distributed file system, storage layer, with a framework that allows you to implement arbitrary logic. First, identify what data you want to extract from your entire data set or a specific data set inside your file system, and then what logic to apply onto that data that you extracted. That framework is called map reduce. Mapping out the data you want to do something with, reduce it down to the results you want to ask your data for. So a framework to operate in parallel and a distributed file system. And then, fair enough, I need to mention Yarn. Yarn is a fairly new piece in Hadoop that enables you more efficient resource scheduling. So as you bring more and more workload to this platform, you need to be aware that each workload takes resources, CPU, memory, and divide that in a fair way or a better scheduling of workloads on the same cluster, right? So that's an improvement around resource scheduling. To process data in the cluster, you need to actually get the data into the cluster. The most common ways of doing that is using either Scoop or Flume. Scoop is the connector that brings structured data into the platform, and which you can also use to export structured data back to your optimized systems for serving if you want to. It's a bidirectional structure connector. Flume is designed to handle more continuously generated events, such as log events or Twitter feeds or sensor data, something continuously populated that needs to quickly land in your cluster for immediate and long-term processing. Next, of course, you want to do something more than just code Java, right? There are other users of data out there, some with SQL expertise. Around Hadoop, there were other projects popping up, such as Hive and Pig, allowing you to use more traditional query languages. So Hive is the SQL translator from SQL to MapReduce, allowing you for batch-oriented SQL queries onto your data, still stored as files. Pig is a more process-oriented query language. It allows you flexibility in how to query on your data. Also translates to MapReduce, processing the data in parallel and returning the results back to you. And then we have a bunch of pre-implemented libraries built for MapReduce. These mentioned here are machine learning libraries, providing algorithms as MapReduce jobs, such as clustering or categorization, or if you want to build a recommendation engine. It's already a set of neat functions to build that out for you. Then last year, I say, was the year where Hadoop was taken seriously. This is where big banks and governments and telcos and healthcare started putting this into production. This is when the technology was that mature and enough production management tools around it was ready to safely bring customers into production. That's where also other needs came around, which required more real-time interaction. Remember, we talked in the beginning about not only providing storage and processing capacity, but also providing the access. You don't want a stale archive. You want interactive archive. So these real-time workloads came around. Impala is the real-time query engine, not batch, real-time. Still SQL-based, just as Hive. Still supporting JDBC and ODBC and all the BI tools, but it's real-time. Then we have taken an effort to integrate Solr, a well-established and mature search engine, with the rest of the platform. So you can enable search across all your data, free text search, just like Google. And then we integrated most recently Spark, which is a real-time processing framework that operates on data in memory instead of on disk. So it's a faster version of MapReduce, if you will. And then a side note, there are also other storage forms, HBase. It's a column-oriented key value store so that you can easily store for a specific key sparsely populated data. Okay, what does that mean? Well, maybe you can envision all the visitors to a website. They are the keys, their session IDs, or their, if you can identify them, their cookies. And then every click they did in that website session. That's sparsely populated because every visitor do not click every link. And it can easily help you scan out what users clicked on a certain link or what users stopped visiting my site after visiting this particular location in my web experience. A lot of clickstream analytics are built on top of HBase. Zookeeper is kind of a background animal. It's taking care of the process failover. HBase, for instance, is a distributed service on the cluster. So is Solr. When one node goes down of the service, someone need to take over that workload. Zookeeper manages that failover and also keeps the configurations up to date. Then we introduced Sentry. This is also along the lines of bringing customers into production for real. When you do that, especially in sensitive environments, you need to provide access control. Now that you bring all these audiences to the same platform, access to all your data, don't you want to control it for what user group needs to access what part of that data? That's Sentry. Then we have Hue and Uzi, which is kind of the end user facing components. Uzi is a workflow scheduler, almost like an orchestration tool, where you can schedule a workflow of jobs. For instance, you ingest some data, you want to ETL process that, cleanse it, you want to aggregate that data with another data set, and then you want to do some high batch queries on that, and then you want to report that to some BI tool. That is a workflow. Those kind of workflows on top of Hadoop you can do through Uzi. And then we have Hue, which is the user interface, the graphical web app, where there are many different applications that allows you to interact with every component in Hadoop. We have the file browser, we have the query application, we have the Uzi workflow designer, we have search application if you want. All these applications allow end users to interact with the data. And that's it. Hadoop in, 10 minutes, 15 maybe. And here, for your records, is Hadoop in English. Now we're finally at the part that I love talking about. What time do I have?
30 minutes.
Perfect. All right, so I can go as long or as short as you want. When you get tired of me talking about this part, start asking questions. Not on the first slide, though. So there are 3 typical use cases that, I spent a lot of time thinking about this before this talk. It's hard to define, but I've distilled it to some top-level categories of use cases. the two most common ones. Number one, ETL offload. This is where, remember, I talked in the beginning about the customers wanting to do what they're used to do, but over larger data sets to meet that fixed time window SLA. So this is addressing that of like, okay, I want to cleanse my data, but now I have twice the financial transactions to process within the same from market closing time to market open time fixed window. How am I going to do that? Or 10 times the transaction load, because people are trading on their cell phones. It's not like they only did it when they came home and sat at their home PC anymore. They do it online all the time. So the trading records that needs to be compliant with US regulations still needs to be processed in the same fixed time window. How do you do that without, exploding your IT budget? That's what people do with Hadoop. They offload that processing, that ETL, or decorating of data. I want to combine two data sets before I store them in the database, because the combination of those data sets allows me of a more optimized infrastructure, or it saves manual processing time. I can streamline that aggregation on Hadoop through a MapReduce job or a Spark job and just scale that better than in traditional systems. I think this first one, yeah, is great. It saves a lot of money, but it doesn't, it's boring, Yeah, okay, you can do that. And that's what most customers do. It's a safe bet to show value on Hadoop, but it's not that inspiring. What can you do with new data, right? That's lurking around the corners that, at least for an innovator like myself, makes me drool, This is just standard ETL, but at larger scale. Ta-da. Second one is for organizations with challenges around keeping siloed data around. So you have one system for billing, one system for customer record, patient records. Let's switch business. Patient records, and then you have various blood values in some other system, and then you have nurses' notes and the medical history, all these copies of data. Perhaps the treatment data is also in the billing system. It gets hard to get an overview what really is going on once a mistreatment happens, or once some insurance claims goes, escalates and gets really, really difficult to solve. You want to quickly get the full view of what really happened. In today's system, you have to go to all these different systems to extract information and kind of manually, almost manually weave that insight together. What those customers that have all these various data sets do with Hadoop is to put that all into Hadoop, serve the different audiences from there. You have free text search for nurses. You have, Impala, the real-time query engine for medical reports over the last 3 months of, medical usage of component A. You have MapReduce for extracting or combining data, doing dedupe of patient names, or weaving together two different identities that should be the same person because it was spelled differently at two different hospitals. All those workloads can be done on the same platform, just storing the data once, and you can still serve all those audiences and give access to that data and a better full view. That's what people do with Hadoop. That's more interesting, but where I really enjoy myself is when I get to talk about the third part. So that's what I'm going to focus on now. I don't really have a label for it, as you see. It's like I don't know what to call it. Advanced analytics doesn't really cover what I mean. But it's more about combining all these data sets, not only to serve that use case, but actually to do something new and different. Here are some examples. On a high level, maybe it doesn't look different. But I think it's cool when you go into a little bit more detail. So that's what I'm going to do. And I need some water before I do that. Are you with me so far? Good. So I picked a few here. Event prediction. What if we could predict the future? That would be exciting. That's what I do on a daily basis. So here we had a customer who, or many customers actually, but I'm going to have one example in my head when explaining this use case. This was a component provider, and sometimes components fail. And if they happen to fail in a region where there aren't any stock components around, the wait for new components can be very long. So the question was, how do we optimize our replacement logistics? Like, how do we make sure the components are there when the customer component fails, or the customer using that component when the component fails? So what they did was extract all the phone home files or logs from all their customers over the last 10 years. All of it in the same platform. And trying to extract patterns. Like, okay, if component A fails and then component B fails, then it seems more often like component X fails too. That's what I mean with a pattern. Or it seems like if we install a new component X, 5 months later that fails. 5 months later that fails. So extracting these patterns over phone home logs to come up with better logistics of, okay, now this customer set has had component X installed for 4 months and 20 days. We're going to send out a replacement component right now, while we, in another part of our organization, also look at improving the process and the durability of component X. So this insight across 10 years of phone home log data and component failure, just one use case on that data, led to a lot of improvements and saving them a lot of money. And also increasing the customer satisfaction, because their customers experienced less downtime because the component arrived before it failed. Make sense? Made sense to them. They were very happy. Saved millions. Anomaly detection, this is something really hot in the fraud, claims fraud departments, in the insurance industry, or in the InfoSec departments in many high-tech companies or banks. That one little outlier that doesn't match the normal behavior. But how do you extract normal behavior? Well, another customer example. You use MapReduce over lots and lots of data from 3 years back to extract patterns again, or calculate distributions. And then from the very same platform where you ingest this data in, you match incoming data with that distribution in the very same platform. And you trigger an alert once incoming values are not within the distribution or not meeting that pattern that you've also calculated on the very same platform. And you can immediately drill down and look at that either through Impala or search and address the problem, validate that it's real, and do something about it. Along that, you get the log storage to cost efficiently scale. You can do more accurate extractions of fraud patterns over 10 years of data instead of 3 months of data, right? You can go and find those tiny anomalies that isn't evident to the human eye. This is the capacity of storing such and executing such a use case on Hadoop. Customer profiling. I'm 50-50 around this because I kind of don't want companies to know too much about me. But on the other hand, it's very nice when I get the big discount on something I really want. So it's like good and bad. But This is a funny story. And it's a good example of what kind of value you can get from looking at unstructured data. So this company had a food product. And they were planning their investment budgets for next year. And they wanted to know what flavor should we invest more in, marketing-wise, right, to increase our sales the most. And all their traditional systems where they've stored all their data show them that vanilla is the thing. You should go for vanilla, it's what customers buy the most. So there was a plan in place to go and invest more in vanilla. It's just that some tiny department in this company went and also ingested tons of Twitter data and extracted their brand name from that data, processed any tweet that had the brand name, right? And looked at, is there any adjective here that, what kind of taste names can we extract? And they knew their tastes, you know, all the production ones and all the trial ones that were popular to have tasting events in different regions. And believe it or not, what really trended on Twitter was pineapple. Where can I find pineapple? I can't buy it. Turns out pineapple taste was a trial run in one region, and then it just spread like a fire on Twitter. Everybody wanted pineapple, while the traditional store data showed them vanilla. So what did they do? They invested a little bit in both, and guess what? Pineapple sold much more. That's what you can find out if you get to combine traditional, you know, the store data, the data you have access to in your, you know, all the transactions from your customers, all the orders, with external data that can give you additional input. Then we have a common question like, why do customers not like us anymore? Boo. How do we prevent customers from turning away from our service? That was a big question asked. And of course, the reports showed, yeah, hey, your customers are declining in number, but it didn't explain why. And here we go into what I think is the one key takeaway, if you want to understand what Hadoop can do for you, is that when you get that alert of like something is wrong, you can go in and understand more in this platform. So how? How did they do that? Well, they had all the information stored in Hadoop. They had the emails with customer support. They had the transactions, whatever. And they also had the voice recordings from their support service, voice recordings. What did they do? They used Hadoop's cost-efficient scale processing power and extracted the decibel level in the support calls to extract the subset of calls where people obviously were upset. And then they went and drilled down into, they used those customer IDs to go and look at their data, their support data, and they realized in that study what happened just before was that they had gone through very, very awkward, you know, phone choose many calls, like maybe 5, 10 calls and many options through their call process, and then were met with this really simplistic support service script. And it got just so much frustration, and I can relate. I mean, you want to get help. You don't want to, you know, have to make 10 calls and get weird, you know, can you provide your customer service number? It's the 10th time. You know, don't you already have this in your system? No, they didn't. So what they did was to optimize that path. And believe it or not, their customer number was adjusted. They did some other things too, but you get the point. Last one. How am I doing on time?
Very good.
I'm good.
15 minutes.
Perfect. Then I get to do a bonus part as well. So how do we increase our online sales? Okay. Did it make the cut of interesting? Maybe it did. What they did was save all the click streams in HBase. They extracted from HBase the ones where people left the site after starting a transaction path, putting items into their cart, but then leaving the cart. Why? Well, it turns out sometimes options are bad. It turns out they looked at these customers. They had other similarities in their profile too, frequency of visits, other sales in the past. But it turns out their ad placement had actually put multiple ads around similar, let's say it's a table. And there were 3 or 4 paths to go to the next level around table, but there were duplicates and there were very similar items. It wasn't clear to the end user what to do. It was not easy to go to the next step because they had actually too many options. So the end user got confused and instead left the cart hanging. What they did was simplify, only present 2 options, not 6 or 7 or whatever it was, and thereby streamline the process to a finished sale over prioritizing like they had in the past of presenting more opportunity to buy. So all those more opportunity to buy options confused the customers instead of streamlining it to close of deal. So they changed their online revenue because of this insight through HBase. Bonus part, 5 minutes. Prepare yourself. How do we solve this? Well, there's a company. These are extremes. You realize I work in this business day in and day out. I have all these big data use cases in my head. These are the extremes that I love. So there's a company who takes images from low altitude, little satellites. The quality of those images aren't perfect, but they use Hadoop to store all images. And then they do some advanced magic image processing of overlaying images to get clear views. Using such a technology, using such parallelized image processing around a very, very large set of images can help rescue teams to understand where it's most safe to land to help pick up people or provide Medicare. They cannot do this in real time or in enough quick time if they didn't have this kind of capacity platform to process that image size. Like, I don't know exactly the number, but we're talking about terabytes of images, right? But they help people by doing this. And that makes me really happy. Another one, how do we prevent suicide? So it turns out the suicide rate among veterans is very high, but there's no research or there's not much information why. Like for some, there's suicide on the agenda and some are not. And this is a very depressing topic, I know, but the ending is good, so bear with me. So there was this company who worked several years to get permission to look at 10 years of medical data for suicide victims. And this is sensitive information, right? It's not easy to get permission from those families affected. But in the end, persistence helped. So this guy created some natural language processing algorithms in MapReduce and stored all these 10 years of data, nurses' notes, phone calls, whatever medical records. I don't have insight in all of the types there. But he did natural language processing and extracted the most common terms used by suicide victims in their communication. And then he created an application that people who wanted to be part of this program could opt in to install on their cell phone to capture Facebook messages, text messages, any kind of communication, phone calls, and get mapped to these patterns, these frequency of usage of words. For instance, I'm fine. Or the, all these little reports of daily activities, whatever patterns he extracted, he could match incoming communication against that and actually mathematically prove there's an 80% likelihood of this person committing suicide soon, so that medical efforts could be put in place to help that individual. And I'm not saying this particular part that I'm going to share now is related, but I heard it on the radio the other day, and I know this went into production, last year or so. Suicide rates among veterans this year has gone down with 20%. I'm not saying it's related, but I think it is, because this guy could figure that out. So how do we reduce world hunger? I mean, seriously, are you looking at these questions? Do you realize why I'm excited about this technology? Here we're looking at an increase in people being born, in people's health. We live longer, and we eat more, and we have a limited set of resources. And nature is changing. So how do you make crops more sustainable so that you can feed humanity forward? Well, one company is looking at images of crops, weaving in external data, weather data, what's in the soil, what equipment was used at that time for that kind of harvest, which geolocation, and saving all that data into Hadoop. And then doing analytics and insights across that to help more sustainable crops in parts of the world where basically nothing can grow. And that's a pretty good cause, I think. And it's amazing to see technology I work on helping that. So, do we want to solve cancer? Yes, please. One use case here is in research. There's so many varieties, so much data. Everyone is an individual. How do we actually do proper research? Well, if you have a large enough data set, you can actually make better conclusions quicker. So a lot of cancer, tumor, DNA data pumped into Hadoop with other medical data, and suddenly processing results that used to take 11 months to get like some new test result over that particular algorithm of processing that kind of tumor DNA data went down to a month or 6 weeks. That's the scale we're talking about. And then global warming, it's nice. It's warm? No, it's not nice. What am I talking about? An energy company decided to extract information about all their customers and make it on a neighborhood basis and send that back to the customers with a comparison on how much you use compared to your neighbors. And using the psychology of human mind of group pressure to lower your costs, lower your usage, and becoming a greener member of this earth. That correlation and processing happen in Hadoop. How do we improve education? Well, here's where you extract where students struggle with online education, right? You can have the traditional reports on, yeah, these many students failed. Is it the teacher? Is it the content? What is it? You can do surveys, but it's always subjective. What if you can get objective data, like actually measuring for every student taking a course how much time they spent on each assignment, if they failed that particular question at the test, and then extract that over maybe 7 years of online students, then you can get reliable insights and do corrections of the course material to speed up more people getting educated. Of course, these are just tiny examples under these umbrellas. There's so much more. Unfortunately, I'm running out of time. So my last comments are just for the road, which is, why Hadoop? Well, it's scalable, it's cost efficient, it's flexible, and it's fun. And why should you think twice? Well, do you have the right knowledge? Maybe you need to go and take a training or get certified or build a team around it before you actually dive in and do something. Recommendation number 1. Maybe you don't have a big data problem. Not everybody does. But remember this, it's not about the size of the data. Sometimes it's about combining data types. And traditional systems aren't really capable of doing that very well. So you might have a big data problem, although big isn't the relevant part. Okay? And is your company ready? Do you have actual investments around building a whole team around it? The successful companies I've seen implementing Hadoop successfully start small. They start often with the offload ETL use case to show value to the rest of the company, to get more investment to build out a team. But once you open the door to that innovative part, trust me, there's no turning back. You can do anything with data. There is no box. Some recommendations to learn more for your reference, and thank you.